a WikiVidi documentaries production. Don't forget to like and subscribe. Enjoy. Engineering. Engineering is the application of scientific knowledge and mathematical methods to practical purposes of the design, analysis, or operation of structures, machines, or systems. See Glossary of Engineering. The discipline of engineering encompasses a broad range of more specialized fields of engineering, each with a more specific emphasis on particular areas of applied mathematics, applied science, and types of application. The term engineering is derived from the Latin ingenium, meaning cleverness, and ingeniare, meaning to contrive, devise. History. Engineering has existed since ancient times, when humans devised inventions such as the wedge, lever, wheel and pulley. The term engineering is derived from the word engineer, which itself dates back to 1390 when an engineer referred to a constructor of military engines. In this context, now obsolete, an engine referred to a military machine, i.e., a mechanical contraption used in war. Notable examples of the obsolete usage which have survived to the present day are Military Engineering Corps, and more, the U.S. Army Corps of Engineers. The word engine itself is of even older origin, ultimately deriving from the Latin ingenium, meaning innate quality, especially mental power, hence a clever invention. Later, as the design of civilian structures, such as bridges and buildings, matured as a technical discipline, the term civil engineering entered the lexicon as a way to distinguish between those specializing in the construction of such non-military projects, and those involved in the discipline of military engineering. Ancient era. The pyramids in Egypt, the Acropolis and the Parthenon in Greece, the Roman aqueducts, Via Appia and the Colosseum, Teotihuacan. The Great Wall of China, the Brihadeeswar Temple of Tanjore, among many others, stand as a testament to the ingenuity and skill of ancient civil and military engineers. Other monuments, no longer standing, such as the Hanging Gardens of Babylon and the Pharos of Alexandria, were important engineering achievements of their time and were considered among the 7 wonders of the ancient world. The earliest civil engineer known by name is Imhotep. As one of the officials of the pharaoh, Djoser, he probably designed and supervised the construction of the Pyramid of Djoser at Saqqara in Egypt around 2630–2611 BC. Ancient Greece developed machines in both civilian and military domains. The Antikythera mechanism, the first known mechanical computer, and the mechanical inventions of Archimedes are examples of early mechanical engineering. Some of Archimedes' inventions as well as the Antikythera mechanism required sophisticated knowledge of differential gearing or epicyclic gearing, 2 key principles in machine theory that helped design the gear trains of the Industrial Revolution, and are still widely used today in diverse fields such as robotics and automotive engineering. Ancient Chinese, Greek, Roman, and Hungarian armies employed military machines and inventions such as artillery, which was developed by the Greeks around the 4th century BC, the trireme, the ballista and the catapult. In the Middle Ages, the trebuchet was developed. Renaissance era. The first steam engine was built in 1698 by Thomas Savery. The development of this device gave rise to the Industrial Revolution in the coming decades, allowing for the beginnings of mass production. With the rise of engineering as a profession in the 18th century, the term became more narrowly applied to fields in which mathematics and science were applied to these ends. Similarly, in addition to military and civil engineering, the fields then known as the mechanic arts became incorporated into engineering. Modern era. The inventions of Thomas Newcomen and James Watt gave rise to modern mechanical engineering. The development of specialized machines and machine tools during the Industrial Revolution led to the rapid growth of mechanical engineering both in its birthplace Britain and abroad. John Smeaton was the first self-proclaimed civil engineer and is often regarded as the father of civil engineering. He was an English civil engineer responsible for the design of bridges, canals, harbours, and lighthouses. He was also a capable mechanical engineer and an eminent physicist. Smeaton designed the third Eddystone Lighthouse, where he pioneered the use of hydraulic lime and developed a technique involving dovetailed blocks of granite in the building of the lighthouse. His lighthouse remained in use until 1877, and was dismantled and partially rebuilt at Plymouth Hoe, where it is known as Smeaton's Tower. He is important in the history, rediscovery of, and development of modern cement, because he identified the compositional requirements needed to obtain hydraulicity in lime work, which led ultimately to the invention of Portland cement. The United States Census of 1850 listed the occupation of engineer for the first time with a count of 2,000. There were fewer than 50 engineering graduates in the U.S. before 1865. In 1870 there were a dozen U.S. mechanical engineering graduates, with that number increasing to 43 per year in 1875. In 1890, there were 6,000 engineers in civil, mining, mechanical and electrical. There was no chair of applied mechanism and applied mechanics at Cambridge until 1875, and no chair of engineering at Oxford until 1907. Germany established technical universities earlier. The foundations of electrical engineering in the 1800s included the experiments of Alessandro Volta, Michael Faraday, Georg Ohm and others, and the invention of the electric telegraph in 1816 and the electric motor in 1872. The theoretical work of James Maxwell and Heinrich Hertz in the late 19th century gave rise to the field of electronics. The later inventions of the vacuum tube and the transistor further accelerated the development of electronics to such an extent that electrical and electronics engineers currently outnumber their colleagues of any other engineering specialty. Chemical engineering developed in the late 19th century. Industrial-scale manufacturing demanded new materials and new processes, and by 1880 the need for large-scale production of chemicals was such that a new industry was created, dedicated to the development and large-scale manufacturing of chemicals in new industrial plants. The role of the chemical engineer was the design of these chemical plants and processes. Aeronautical engineering deals with aircraft design, process design, while aerospace engineering is a more modern term that expands the reach of the discipline by including spacecraft design. Its origins can be traced back to the aviation pioneers around the start of the 20th century, although the work of Sir George Cayley has recently been dated as being from the last decade of the 18th century. Early knowledge of aeronautical engineering was largely empirical, with some concepts and skills imported from other branches of engineering. The first PhD in engineering awarded in the United States went to Josiah Willard Gibbs at Yale University in 1863. It was also the second PhD awarded in science in the US, only a decade after the successful flights by the Wright brothers. There was extensive development of aeronautical engineering through development of military aircraft that were used in World War I. Meanwhile, research to provide fundamental background science continued by combining theoretical physics with experiments. In 1990, with the rise of computer technology, the first search engine was built by computer engineer Alan Imtage. Main branches of engineering. Engineering is a broad discipline which is often broken down into several sub-disciplines. Although an engineer will usually be trained in a specific discipline, he or she may become multidisciplined through experience. Engineering is often characterized as having four main branches: chemical engineering, civil engineering, electrical engineering, and mechanical engineering. Civil engineering. Civil engineering is the design and construction of public and private works, such as infrastructure, bridges, tunnels, dams, and buildings. Civil engineering is traditionally broken into a number of sub-disciplines, including structural engineering, environmental engineering, and surveying. It is traditionally considered to be separate from military engineering. Other branches. Beyond these Big Four, a number of other branches are recognized, though many can be thought of as sub-disciplines of the four major branches, or as cross-curricular disciplines among multiple. Historically, naval engineering and mining engineering were major branches. Other engineering fields sometimes included as major branches are manufacturing engineering, acoustical engineering, corrosion engineering, instrumentation and control, aerospace, automotive, computer, electronic, petroleum, environmental, systems, audio, software, architectural, agricultural, biosystems, biomedical, geological, textile, industrial, materials, and nuclear engineering. These, and other branches of engineering are represented in the 36 licensed member institutions of the UK Engineering Council. New specialties sometimes combine with the traditional fields and form new branches. For example, Earth Systems Engineering and Management involves a wide range of subject areas including engineering studies, environmental science, engineering ethics, and philosophy of engineering. Methodology. In the engineering design process, engineers apply mathematics and sciences such as physics to find novel solutions to problems or to improve existing solutions. More than ever, engineers are now required to have a proficient knowledge of relevant sciences for their design projects. As a result, many engineers continue to learn new material throughout their career. If multiple solutions exist, engineers weigh each design choice based on their merit and choose the solution that best matches the requirements. The crucial and unique task of the engineer is to identify, understand, and interpret the constraints on a design in order to yield a successful result. It is generally insufficient to build a technically successful product, rather, it must also meet further requirements. Constraints may include available resources, physical, imaginative or technical limitations, flexibility for future modifications and additions, and other factors, such as requirements for cost, safety, marketability, productivity, and serviceability. By understanding the constraints, engineers derive specifications for the limits within which a viable object or system may be produced and operated. A general methodology and epistemology of engineering can be inferred from the historical case studies and comments provided by Walter Vincenti. Though Vincenti's case studies are from the domain of aeronautical engineering, his conclusions can be transferred into many other branches of engineering, too. According to Billy Vaughan Cohen, the engineering method is the use of heuristics to cause the best change in a poorly understood situation within the available resources. Cohen argues that the definition of what makes one an engineer should not be based on what he produces, but rather how he goes about it. Brought to you by WikiVidi documentaries. Would you like to know more?